tersebut tak dapat nak dengar jawapan tu. Dia macam lagging lah. Okay, now I share the screen already. Okay, let's start about this. Okay, factors affecting the reaction rate. So these are the learning outcomes that we will cover. Please look at the A learning outcome. The effect on the reaction rate, we will study about four factors. Not four effect, four factors. What is the effect to the rate of reaction if we manipulate the factors? First is concentration or pressure, second temperature, third catalyst, fourth particle size. And then for the effect of temperature, we will be using Maxwell-Boltzmann distribution. Okay, this is the continuation, Arrhenius equation, all this the last part. Okay. First factor is concentration or pressure. Concentration, reaction rates generally increase as the concentrations of the reactant are increased. Concentration of reactants increases. What will happen when we increase the concentration of reactant? Number of molecules per unit volume increases. Number of effective collision increases, and therefore the rate of reaction increases. So the most important point over here is 0.345. When we increase the concentration, number of molecules per unit volume increases. Bilangan molekul itu per unit isi padu, dia akan bertambah. Bilangan molekul lah, kuantiti dia bertambah. Bila kuantiti bertambah, maka pelanggaran berkesan pun bertambah lah. Effective collision bertambah, maka kadar tindak balas or rate of reaction bertambah. Okay, ini faktor pertama. Untuk pressure, factor pressure ni kita bincang untuk gaseous reactant yang berada dalam fasa gas lah. So bila pressure bertambah, isi padu berkurang, number of molecules per unit volume increases, number of effective collision increases, thus the rate of reaction increases. So similar to concentration, cuma perbezaannya adalah reactant kita dalam fasa gas lah. And then we will have same explanation, except the first point a bit different here, because we know that pressure is inversely proportional to volume. So when we increase the pressure, the volume would decrease. Okay, that leads to the number of effective collisions being increased. Okay, factor number 2. This is very important factor. Okay, maybe I will mix this with Jamboard explanation. Okay, temperature. The effect of temperature on the reaction rate can be explained in terms of kinetic theory. The average kinetic energy of molecules are proportional to the temperature. This one everyone knows that. That means if the temperature increases, kinetic energy of the molecule will increase. At higher temperature, more molecules will have higher kinetic energies than at lower temperature. So at higher temperature, number of molecules having kinetic energy equal to or more than activation energy will increase. Frequency of effective collision increases. Reaction rate increases. Okay, this one I will explain more detail when we use the Maxwell-Boltzmann distribution. Okay. This is Maxwell-Boltzmann distribution. So I stop sharing this one for a while. We go to the Jamboard. Later we come back to this one. Okay, so now I would share the Jamboard. Okay, so all can see Jamboard ni. Yeah. Okay, please look at the Jamboard. We are going to see Maxwell-Boltzmann. Okay, so Maxwell-Boltzmann, right? Maxwell-Boltzmann. So first, I read there, Maxwell-Boltzmann distribution. Maxwell-Boltzmann distribution. Okay, first we learn how to draw the curve. Okay, this is, sorry, we have. I request everyone to draw together with me. This is axis Y, and this is axis X. Okay. Okay. It's axis Y. So this we label as the axis Y. Axis Y we label as number of molecules. Number of molecules. Number of molecules. Okay. And then the axis X we can label as kinetic energy. Kinetic energy. Ada buku yang guna molecular speed. Molecular speed. So both are same actually. Kinetic energy pun boleh, molecular speed pun boleh lah. I take kinetic energy lah. More related lah. Okay, now we will have two temperature. Let's say we have T2 and T1. Two temperature, T2 and T1. And the condition we set here is T2 greater than T1. Okay, T2 lebih besar daripada T1 greater. Okay, so kita akan lukis curve T1 dulu. Curve T1. Curve T1 ni, this curve T1 will be narrow. Sorry. Alamak. Sorry. Curve T1 will be narrow and tall. Narrow maksudnya kurus. Kurus dan tinggi macam tu lah. So, I draw T1. Okay. This is label sebagai T1. T1. Okay. Now T2 pula dia macam mana narrow, wide lah. Wide wide and short. Okay. Lebar dan pendek macam tu lah. Lebar dan pendek. So lebar dan pendek macam ni. Okay. This is T. Okay. Dia lagging sikit. We wait for a while. Can you hear me, guys? Dengar ke? There's now lost connection.
Yes, sir. Yes, sir.
Nah, can you hear me?
Yeah, can sir.
Yes, sir.
Okay, sorry, just now lost connection a bit.
Yes,
Okay,
sir.
now I explain again. So we will have two curves. One is for T1, one is one for T2. Good. One is for T1, one is for T2. Okay. You will find the T1 is narrow and tall. You will find the T2 is wide and short. And then the average, the maximum speed, you can see here. The top of the peak is the maximum speed. Okay. Top of the peak is the maximum speed. Okay. Top of the peak. Okay. Now our concern is, I write here. The first concern is EA, the activation energy. Okay. Activation energy, if you have watched my 8.2 video under collision theory, saya dah terangkan EA itu apa. EA adalah activation energy, tenaga yang diperlukan untuk initiate satu chemical reaction. Okay. Minimum energy required for a particle to initiate. Let me see whether I got here or not. Just a moment. Oh, this is 8 point. Yeah. Okay. I just share for a while, because I scared. Where is it? Okay, just a moment. Other than this one, I stop for a while. Stop sharing. I'll come back to this one. We share this one. Window. We look at definition for activation energy. Okay. This is, I make it bigger. Can you all see the activation energy definition? Can you all see?
Can, sir. Can, sir.
Can, alright. This is activation energy. Sebab ada yang tanyakan apa tu activation energy? Tenaga pengaktifan. Minimum energy required for effective collision to occur. To initiate a chemical reaction lah. Minimum energy. So, let me see. In terms of, this is called energy profile diagram. Okay. And this is for exothermic reaction. So this is reactant, this is product, and this is activated complex. So what would happen is, this is activation energy. Okay. Now what will happen? The reactant will overcome the activation energy to form product. The reactant has to overcome the activation energy to form the product. So activation energy is the minimum energy required to initiate a chemical reaction. Itu activation energy. Okay. Coming back to our Boltzmann distribution. Coming back to the Boltzmann distribution, that is activation energy lah. Saya nak terangkan tu apa activation energy kan. Okay. Coming back to this, our Jamboard for the Maxwell-Boltzmann. So in Maxwell-Boltzmann distribution curve, kita kena letak activation energy. Okay. So what I will do here, I will draw a line like this. Okay. Just a line, and then we label this one as activation energy. Okay. Meaning to say, this part over here, the reactants, okay, the other side of the left-hand side of the EA, okay, the particles, reacting particles, if they can overcome this activation energy, okay, these reacting particles, if they can overcome the activation energy, okay, they overcome the activation energy, they will form product. Okay, right. And when they want to form product, okay, it depends on how much products can be formed at T2 and at T1. Okay, berapa banyak produk boleh terbentuk di sini atau berapa banyak reaktan yang dapat melepasi EA ini untuk jadi produk bergantung kepada faktor temperature. I repeat one more time. This is the EA. Okay, particles has to overcome the EA to form products, reacting particles. So this will show number of reacting particles at two different temperature. Okay, so kita buat conclusion yang kedua. Saya akan shade dulu. Kita shade dulu area under the curve. Okay, kita kata area under the curve. Ini keyword yang kedua, area under the curve. So perhatikan T1. Look at T1. So this is the area under the curve. Okay, so kita shadekan dia. Okay, area under the curve lah, 41. Then 42, this is the curve. T2 ini curve dia. Ini area under the curve lah. Okay, that is the area under the curve. Okay, so we shade that. Sorry. Okay, now I would like to ask you, in your opinion, T1 or T2, which one has greater area? T2 or T1? Mana kawasan Bolore dia lagi besar?
T2.
Yes, New?
T2.
T2, okay. So area under the curve of T2 is greater than T1. Okay, area under the curve of T2 greater. So we have to make a conclusion here. That means bila kawasan berlori T2 tu lagi besar daripada T1, maksudnya lagi banyak reactant particles melepasi EA pada T2. I repeat one more time. Kalau kita nampak kawasan berlori untuk T2 lebih luas, lebih besar, maksudnya lagi banyak reacting particles melepasi EA pada suhu yang lebih tinggi, iaitu T2. At higher temperature, more molecules now having energy greater than activation energy. Now, why it is so important? Once you overcome the activation energy, that means you are eventually can be product. Product can be formed. And that leads to the idea of when the temperature increases, the kinetic energy increases. Now molecules, yeah. Okay. Any problem? Okay, I repeat again. Okay, when we have higher temperature like T2 greater than T1, we already decided that when the temperature is higher, T2 is higher than T1. At this higher temperature, lagi banyak molekul yang mempunyai tenaga kinetik yang lebih tinggi daripada tenaga pengaktifan ataupun activation energy. Now, once you overcome the activation energy with greater energy, kinetic energy, then is effective collision. Maksudnya produk terbentuklah. So the rate of reaction increases at higher temperature. That is Maxwell-Boltzmann distribution. Okay, these are the three important things you need to know under the curve. That's all. Clear, guys? Boleh ke?
Boleh, sir.
Answer.
Boleh Ini Maxwell-Boltzmann kena baca banyak. Saya boleh terangkanlah, tapi pembacaan tu akan bantulah. So more particles will having energy equal or greater than activation energy. That means kalau more particles, then you know lah. If there is more particles already, that means the probability of effective collision will increase. Setuju tak dengan saya? Kalau lagi banyak molekul terlibat dalam pelanggaran, kebarangkali pelanggaran itu menjadi pelanggaran berkesan tu adalah lebih tinggi. Betul?
Betul, sir. Betul, sir.
Bila effective collision tu kebarangkalian tu lebih tinggi, maksudnya kita punya rate of reaction akan bertambah lah, memang tinggi lah. Okay, alright. That is Jamboard. So kita patah balik kepada nota. Sebarang nota ada penjelasan. Kita tengok dia punya penjelasan pula dari segi point apa yang dia cuba terangkan. Okay, mana tadi Maxwell-Boltzmann? Okay, sini ada Maxwell-Boltzmann. Okay, dapat tengok slide Okay, saya besarkan slide lah. Okay, the shaded area represent number of molecules having kinetic energy equal to or greater than activation energy. Itu kawasan berlori yang saya tunjukkan tadi lah. At higher temperature, iaitu T2, number of molecules having kinetic energy equal to or more than activation energy increases, kan? Kawasan berlori lagi besar, maksudnya lagi banyaklah molekul yang mempunyai tenaga yang sama dengan atau melebihi activation energy. Lebih banyak molekul, That means, secara kesimpulannya, pelanggaran dia bertambah. Rate of reaction bertambah. So, ini adalah explanation untuk factor number 2, temperature. Okay. Now we go to catalyst. Catalyst is a substance that increases the rate of chemical reaction without itself being consumed. A catalyst provides an alternative pathway which has lower activation energy compared to the one without catalyst. Okay, I want to tell you before that, kalau soalan tanya how does catalyst work, jawapannya adalah point number 2, ataupun what is the function of catalyst pun jawapan number 2. Tapi kalau ditanya what is a catalyst, jawapannya nombor 1. What is a catalyst? A substance that increases the rate of chemical reaction without itself being consumed. Ataupun define catalyst lah. Tapi kalau ditanya function catalyst ataupun how does catalyst work, Macam mana catalyst berfungsi? Dan jawapannya nombor 2, provides an alternative pathway which has lower activation energy compared to the one without catalyst. A comparison of activation energy of catalyzed and uncatalyzed reaction. Okay, kita tengok diagram ini. Ini diagram namanya energy profile diagram. Untuk makluman, energy profile diagram ada dua, satu exothermic, satu endothermic. Yang ini adalah untuk exothermic. Okay. So E1, kalau perhatikan E1 without catalyst, E2 with catalyst. So apa yang kita nampak, apa yang anda nampak beza tu? With catalyst dengan without catalyst. Ada beza tak?
With catalyst, the activation energy is lower.
Okay, good. Kalau you tambah catalyst, itu bukit jadi rendah. Betul?
Betul.
Kalau tambah catalyst, bukit jadi rendah. Now soalan saya adalah, mana bukit senang dilepas? Bukit yang rendah ke bukit yang tinggi?
Rendah.
Rendah. So pada pendapat anda, kalau bukit yang rendah kan? So kalau pada pendapat anda, kalau bukit yang rendah tu senang dilepasi, you rasa siapa lebih senang bentuk produk? Dengan catalyst ke tanpa catalyst?
With catalyst. Dengan catalyst.
Dengan catalyst. Sebab bukit rendah senang nak lepas kan? Reacting particle tu senang nak lepas bukit. Yes, very good. Reactant boleh lepas itu bukit yang rendah dengan lebih mudah untuk jadi produk. Maka kita membentuk produk dengan lebih cepat lah, lebih cepat. So kadar balas bertambah. Rate of reaction is increased with catalyst. Okay guys?
Okay,
So that is
sir.
the explanation.
Okay, sir.
Okay. Alright, factor number 4, particle size. Size of reacting particles smaller, total surface area exposed increases. Ini two key sentences untuk particle size. Especially number 2 tu sangat penting. Bila size kecil, total surface area yang exposed tu menjadi sangat besar. So frequency of effective collision bertambah, maka reaction rate pun bertambah. Okay, this is more direct lah. Macam mana kita nak bezakan size particle tu besar kecil? Satu kita gunakan solids, satu kita gunakan powder. Okay. Contohlah saya kata copper 1 oxide kan. Kita ambil solid ionic compound, kita letak dia dalam ketulan-ketulan besar, kemudian kita tumbur dia jadi serbuk. So yang serbuk tu dia punya size sangat kecil, dia punya surface area sangat besar. Yang ketulan-ketulan solid tu dia size besar tapi surface area dia kecil. That's the difference lah. Okay, the last part of chapter 8, Arrhenius equation. The relationship between the rate of constant of a reaction and temperature can be expressed by Arrhenius equation. Ini dikenali sebagai Arrhenius equation. Kalau anda ingat lagi, masa saya terangkan KCKP ataupun KAKB lah, saya pernah bagi tahu semester 1 ada satu persamaan yang dinamakan sebagai Arrhenius equation, satu formula di mana rate constant tu, not rate constant, equilibrium constant ataupun acid base constant ni hanya boleh alter menggunakan temperature. Inilah equation dia, Arrhenius. So in chapter 8, our focus is rate constant, bukan equilibrium constant, rate constant. So rate constant ni can be only altered by the changes in the temperature. Okay, because the rest is constant. Okay, perhatikan activation energy for a reaction is constant. Kalau kita kata H2 tambah kalau kita kata N2 tambah 3H2 produces 2 ammonia, itu reaction Activation energy fixed, dia tak berubah. So activation energy is fixed for particular reaction, dia takkan berubah. So dia constant. K memang rate constant lah, kita kena kira. R ialah gas constant, anda tahu. Absolute temperature, ini yang kita akan manipulate. Kalau kita manipulate absolute temperature, rate constant kita akan berubah. Okay, E is the base of natural logarithm scale. That one mathematically you know. A is known as frequency factor. Okay, frequency factor or collision frequency pun fix untuk satu chemical reaction. So yang berubah sekarang ini, kita manipulate absolute temperature, respond. Okay, this is Archimedes equation. However, the application, ada dua saja application di bawah Archimedes equation. Satu, kita kena plot graph dan cari activation energy. Yang kedua, cari rate constant yang baru sekiranya temperature diubah. Only these two questions has been asked in previous years. So we have two things to cover. One is plot a graph, find the activation energy. Number two, if you are given two different temperature, find the rate constant of the later. Okay, this equation can be expressed in a more useful form by taking the natural logarithm of both sides. Ini derivation lah, more to derivation. So you can see here, the equation shows that rate constant increases as temperature increases. Rate constant decreases as activation energy increases. This is mathematical relationship lah. Okay, rate constant increases as temperature increases. Rate constant decreases as activation energy increases. More to mathematical relationship. Okay, this equation can take, the equation can take the form of a linear equation. Okay, this one, like I explained just now, in my linear graph method, I use the linear equation. Okay, so you can see here, our y is ln k and is 1 over t. Okay, please take note. Our y is ln k, x is 1 over t. There's an interception at axis y, that is ln a, and the slope is negative EAOR. Okay, let's look at the pattern of the graph. Ini graph yang anda dapat. Okay, and then kita boleh cari delta y over delta x untuk cari dia punya gradient. Then we also can get from the gradient our activation energy, because R is a constant. R is ideal gas constant. So gas constant ni dia sentiasa kekal lah. So gradient kita cari daripada graph. Sudah tahu nilai gradient, sudah tahu nilai R, maka activation energy boleh dikira. Another important note about activation energy is the unit must be, take note, must be kilojoule per mole. Okay, and one more thing, the interception on the y-axis is ln A. Okay, this is the example. I don't want to discuss this one here because kita kena practice. Cerita-cerita pun tak guna jugalah. Okay, ini jawapan dia lah. This one you can see in the notes. I'm not more into this. Actually, I want to discuss the question. Kita kena practice hands on lah. Okay, this is the last formula. The rate constant of a reaction varies with temperature. If the rate constant at temperature T1 is given, the rate constant at T2 can be calculated using Archimedes equation. So, anda tengok formula dalam box hijau ini. Okay, dia ada dua kemungkinan. They give you K1 and K2 value and T2 value, suruh cari T1, ataupun dia bagi T2 dengan T1 value dan dia bagi K1 value, dia suruh cari K2. So dia boleh manipulate formula ini dalam pelbagai cara lah. Okay, this is derivation not required. Okay, this is the example and this is the answer. Anyway, this one not my concern also. We are going to calculate this. Okay, so that's all chapter 8. Chapter 8 dah habis. So that means now we have to, we have to practice some questions lah. Okay, before that, I give you few minutes to digest what we have learned so far. Okay, cuba tengok 8.3